Okay, so here we go. Woodshop wall construction project. This is the next big project after you complete your cutting board and your small box. What we'll be doing is we'll be diving into kind of the generalized view of construction. One of the other big things that wood shops do, and how that applies to building a wall. We're not really going to get into the how walls go together to build a house, unfortunately, because we don't have the time to do that. But we'll talk about it in this presentation. So, where to begin? Learning target. Given the attached print, tools, and materials such as 2x4s, you'll be able to construct a wall within 1/16th. That would be what we call a tolerance. Tolerance is basically if it's a 16th more or 16th under, it's good. And it doesn't just apply to a 16th. We can look at anything from a 32nd, a thousandth of an inch, all the way up to several inches. The larger the construction, the tolerances get a little bit looser. Not because we want things to be out of square or not plumb, but just because it's the nature of the beast. Though we try to keep within that specification. So within 1/16th specification that has studs 16 inches on center, a header, and a door opening. The wall that you're going to hopefully be producing, it's not a true wall opening. I wanted to maintain the 16 inches on center, and we'll look at this much later on in this presentation. But making sure that it's as real as possible without requiring us to build something giant. The wall will also include an outlet, a light and a light controlled by a switch. So we'll also be going over some of the general electrical work. In this document, you will find information about how to properly construct a wall and how to integrate it into a larger structure. There is also information about how to properly wire it. That should be and, not and. Outlet, light, and switch. The wall, specifically, the wall will have a top plate, a bottom plate, 4 studs. Will be placed 16 inches in the center. There will also be a jack, trimmer, and trimmer studs that support the header. You will construct a header that is installed with 2 jack studs. You will be given 3 boxes that will have a switch, a light, and an outlet in them when done. The switch will control the light, and the light and the switch will be fed off of the outlet. So we'll get into that later, so it's not too important right now. The feed from the outlets will come from a pigtail that is connected to the outlet. This will be to test. What that last piece means is that you have to leave basically a piece of wire exposed so that I can plug it in and see if the thing works and hopefully doesn't catch on fire. So here we go. This is the wall you're going to build. Let's see. So these studs, starting from this edge, 16 inches to the center of that one, 16 inches to the center of that one, 16 inches to the center of that one. We'll get into that a little bit more. That's the standard spacing for studs. The wall is 4 foot by 4 foot outside dimensions. There are a couple different ways to do that to be within that tolerance that we talked about when cutting your 2x4s. And then this header is to help transfer the load that would be above it, because we would theoretically have a larger space than 16 inches. So this is just more representative of what's going on than actually what's happening. We see this in larger openings, again, to transfer weight. And you always want to make sure anything above is supported below. We'll talk about that a little bit more later. And these dimensions all work out pretty well. For the most part, our lumber is a little bit variable, so I might need to double check this one that I'm pointing at right now. Okay, here we go. Framing carpentry and electrical wiring. So basic stud layout in framing carpentry. We just mentioned this when looking at the print of the wall that you're going to build. Basic stud layout in framing is 16 inches on center. which means if you were to split this 2x4 in half and then measure to the center of this next one, split in half, it would be 16 inches. We start on the outermost edge, so we don't have to hook anything in a weird way. So think about your tape measure. You want to be able to hook the tape measure on the edge of the wall, or whatever you're laying this out on, and pull it all the way down. So if we started someplace else weird, we'd have some issues. One of the other things is 2x4s. They're not 2 inches by 4 inches. I have this a little bit later when talking about lumber selection and how to use it. But a 2x4 is actually 1.5 inches wide by 3.5 inches. So this dimension right here is 1.5 inches wide. Again, if you were to split it down the center, that means that there would be a line at 3/4 of an inch. So 1.5 inches wide, or thick, depending on how you look at it, and then the other dimension is 3.5 by whatever length. So 16 inches on center. Memorize it. Learn to love it. Don't forget it. One other thing. You see how this goes 16 inches, 16 inches, and then we get into this tail end here? Your last bay can be variable because you can always figure out where the wall ends. Normally we're pulling left to right. Excuse me. So 16 inches all the way down on center, and then your last bay, which is the space in between the studs, that one can be short. We generally don't want to go long. Okay, moving on. This looks like a whole bunch of garbage and nonsense, but it's not. This isn't necessarily a plan, but this gives you an idea of what a framed wall might look like. Think about what's included in that wall. You'll see windows, doors of different types. You can have sliding glass, so you have a larger opening necessary. You can have transom windows, which are long and narrow. You can have your general double hung windows that open. You can have any number of different styles. So you'll have different ways to do that. You see this load-bearing header right here. We free span. I don't know why they decided to put a non-load-bearing header in this example. This is an example of a non-load-bearing header, but this wall would generally be an exterior wall, which means that most likely it would be load-bearing. And with that, you would want to see some type of load-bearing header. A header, again, is something that transfers the load above. And we use these 16-inch on center studs basically to support everything above so that we don't get sag. Most of you have probably been in a house that the floor or part of it has started to sag, and that's because there's not enough support or things have deteriorated in such a way that excuse me, that allows for, so like if this 2x4 was removed for some reason and then just sheetrocked over, you might see cracking in the sheetrock because this whole piece is starting to, descend. So you see our 16 inches on center referenced here. Our header. The other thing is that the strong way, so everyone's probably stood on a 2x4 for various reasons that's listening to this. If you stand on it the flat way, if you were to put it, let's say, on the tailgate of a truck, and then, and I'm not condoning this or telling you to do this, but this is so that you understand that there is a stronger orientation and a weaker orientation for the 2x4, and that comes down to the way it's cut and the grain of the wood. If the face, so the 3.5 inch wide section, if you place that on the tailgate of a truck and then the other end on the ground, and you put your foot on it, it'll flex quite a bit. If you were to turn it up and put it on the tailgate and the ground and put your foot on the 1.5 inch end, it's not going to flex. And I'm not telling you to do this. Again, I am not telling you to do this. Don't get up, walk out to your parents' truck, and start jumping on a 2x4. Please don't do that. What I'm trying to convey to you is that that 2x4 is more rigid up on end if the load is being borne or bearing on the 1.5 inch side. So that would be, see how this is probably a 2x8, I'm guessing, in this picture. I don't see a dimension on it. But see how it's vertical? This is the face. You can see my pointer here. Okay, so this is the more rigid way to put it. Same thing with a 2x4. Granted, see how these plates are? They are with the weaker end down, but they are supported every 16 inches by a stud. Hopefully you can see that. Okay, so, oops, sorry. Door and window openings are built to accommodate prefabricated units. If you're going to buy a door, you're probably not going to make it. Excuse me, you're going to buy a door, you're probably not going to make it. There are instances, and if you're going to build doors, awesome. You will be very skilled. Also, same thing with windows. You're going to buy a pre-built window. They have what we call rough openings. Those rough openings are designed, excuse me, the rough opening is in the wall or what you have framed. So this right here is a rough opening. You can see it right here. Those rough openings are sized to the window or door as it is sold. When we put a window in here, we normally have to use what's called a shim, or same thing with the door, and that's to take up that extra space. Houses move. You may think they're static, but everyone's been in one on a cold day where you hear stuff popping and moving, and that's because they are moving. Or on a hot day, this is the exact opposite. So, as I said, houses move, and we're also trying to use a universal sized window. So like one person might put it up in here, and they're a little bit off, and again, going back to tolerances. So, we want to give ourselves room so things don't jam up. Everyone probably, not everyone, but a good number of people probably have a door in their house that doesn't quite close right in the winter after the frost gets into the ground. That's because the house moves, and we want to leave enough room that we're not allowing breeze to come through the door, but we want to make sure that as things move and change, the door doesn't get stuck, because that would really suck if it was a front door and you couldn't get it closed in the winter months. Let's see. We talked about sagging of if we don't have enough support from up ahead. I really wish this thing would go away. This thing right here. It's annoying. Yeah. Okay. So, plates, jack studs, headers, trimmers. So we talked about headers. Load bearing and non-load bearing. You'll sometimes see the non-load bearing ones in interior walls. As I said, I don't understand why they put this. This generally looks like a exterior wall. The reason is a lot of interior walls don't have anything sitting on them up above. There are, for larger free-spanning houses, you'll see some, not free-spanning, excuse me. For larger houses, you'll normally see interior walls that do support structures above and below. So we have here, let's start with the window. We have our header. Above we have cripples. That's basically still at a 16-inch on center. That's basically if you were to cut off 2/3 of a 2x4 or 1/3 of a 2x4 and leave one above the header and one below the opening. So above the header, below the opening, and what they're doing is, again, they're allowing for continued transfer of load. So what happens here is that load comes down, and we'll talk about this later. So there's weight up here, it comes down, it's transferred to the header, comes down through the trimmer because it's supporting the header, and then it goes down to ground, the foundation, or some type of supporting structure underneath. The king stud is the outermost stud, and this one does not necessarily end up 16 on center. It's wherever the opening ends. Okay? So 16 on center, 16 on center, you might get lucky. It might be 60 on center and you just move on. But the king stud is oriented at the outermost of the opening. And the same thing with the trimmer. You'll also see them called jack studs. Trimmers are a little bit... I've seen them both ways. And you'll hear people talk about them differently. A jack stud generally has that load bearing. Trimmer, less so. But this one goes all the way down to ground, so it's neither here nor there. Let's see. Header here, jack stud, king stud. So if you think about the king stud, that's the outermost limit on your opening, be it a door or a window or anything. And then you have your header, and your header is supported by a jack stud. So king stud defines the opening, jack stud supports the header, or trimmer supports the header. Let's see. Sill is the lower portion, so where the window, you've all heard this, excuse me, the window sill, that is the lower defining boundary of a window opening. Again, we're looking at rough openings here. You won't have, for a door, especially a prepackaged one that you buy, they'll come with what we call the threshold. This is not one of your questions. Let's see. They'll actually have a piece that slides in here. So 99% of the time, there's probably some weird thing, but 99% of the time you actually don't have that plate carry across, and that's the other thing. So plates, they're the top and bottom defining parts of a wall. They basically contain our wall vertically, and they allow us to put our studs together. Most wall sections are assembled on the ground and then stood up as a piece after they're squared, which means making sure that they're 90 degrees in all corners and all studs are 90 degrees. So your walls will it also allows for weight to be borne from above and then transferred into the studs is by those plates. But you want to make sure that you're not putting weight, and you can see where this says double top plate. I'm just using this as an example. You want to try not to put weight in between the plates, in between the studs. You want to try to always hit the studs, and this is one of those instances where it starts with your orientation of your plate. So this one's a little bit off, but you want to make sure that any seam for a plate is over over a stud. This one's a little bit off, but and then you stagger those seams. It actually adds a level of rigidity. And when you get into the corners and you come to a 90-degree corner for two walls meeting, what will happen is you'll actually overlap, and it actually starts tying the walls together. I don't have a great example of that, but basically you'd leave this one short and the 2x4 from the other wall that would be coming out of the screen. So if you were right here, you can see my pointer. There was a wall coming out of the screen. The top plate would sandwich in there and complete the run and actually help start that tying together process. So let's move on from here. So we talked about headers, cripples on the bottom, cripples on the top. It's basically to continue that transfer of load. Let's see, we talked about top and bottom plates, making sure that they, unlike this one, try to hit studs. Bottom plate isn't as important, but it's not a bad idea. Top plate a little bit more, because you want to make sure that you don't have something sagging or hanging. If there's weight above it, always make sure you're hitting a stud. Double plate helps tie things together. Talked about the sill, trimmer, king, or jack studs. And moving on. Okay. Laying this stuff out. There is a way to do this. Start with the plates. If you start with the plates, your top and your bottom of your wall will be symmetrical. What I mean by that is that if you start by laying out the plate, All you have to worry about is getting it right once instead of laying one out, then laying the other one out, or trying to hold the tape measure while everything's on the floor. I know it's hard to tell about what I'm talking about, but you see how this guy has his top and bottom plate next to each other? He's using a speed square after he's marked out where his 2x4s go. He also marked out where his other walls are going to connect. Actually, you can see on the floor here, it's a little vague, but that is where another wall might come in for a closet or storage area or something. Let's see here. Where to begin? So, 2x4s, 1.5 wide. That's the way we're laying out. If we go all the way back up here, 1.5 wide, 16 on center, back down to here. We start by marking out 16-inch spacing in between. What I recommend you do is do 16 inches on center, put a mark where each one of them goes. 16, your tape measure is marked, is highlighted at 16-inch intervals, 16, 32, 48, and so on and so forth. Once you've done that, go back and 3/4 of an inch on either side, put a mark. So, you have 16 inches, you go to 16 3/4, you go back to 15 1/4, put a mark on either side. Draw a line with your speed square there, not at the center. When you do that, you will have lines that allow you to indicate where each edge of the 2x4 will go. Excuse me. By virtue of doing that, you will be able to align your 2x4s on your bottom and your top plate more easily. Again, not having to screw around with a tape measure or anything. You can just put them between the lines, nail them or screw them depending on what you're doing. In our case, it'll be nailing, and it'll be hand nailed, even though in construction we've moved normally to using either an impulse style nailer, like a pass load, or an air actuated nailer. We're going to hand nail our stuff because nail guns can be dangerous, and we don't have any. Okay. Laying out your studs means to make lines where your edges of the studs will go when nailed or screwed into place. Let's see. Oh, drawing the X, that helps you indicate where your studs are going to go. You see how this guy has 3 studs stacked up here? That allows him to better orient things. Okay. So, to recap, laying out studs. Top and bottom plate together, hook your tape measure, pull it out, lay it out 16 on center, and then, once you've done that, go back through 3/4 of an inch on either side of 16, so it's 16 3/4, 15 1/4, put a line. That will give you an edge reference on your top and bottom plates, so you can just lay your top plate out, lay your bottom plate out. We're going to be dealing with 4-foot studs, so they'll be 4 foot apart. Place the stud in, nail them in place, and you should be pretty close to where they want to be. Okay, so once we put a wall together, there's some considerations. First off, we might not always... So what you're doing is basically building this wall right here. Couple things you need to do. First off, you need to think about where other walls, non-load bearing walls, like this interior wall right here, could separate a bedroom, could be a closet, who knows. You need to consider making sure that it doesn't wobble, because you're going to be not really you'll have some tie-in up above at the top right here, but it's not as explicit as this wall is an exterior wall. There'll be floor joists on it, or a truss or something. What you want to do is you need to consider making sure, again, that it's tied in enough that it's not going to wibble wobble, so back and forth and be all crazy. You want to make sure that it's secured. So we put some blocking in here. That'll tie the wall in, and then we want to make sure that um, depending on how it is, we might change our overall height, or we might integrate it also in that plate system that we saw before. We just want to make sure that it's nice and sturdy so that when we put sheetrock on, and sheetrock, for those of you who aren't aware, I might have mentioned it once before in class, but sheetrock is the stuff that you see with the paint on it. It is a board that is comprised of paper on either side. One's a more finished, one's a little bit more rough. There are different types, some for bathroom use. And then the center is like, it's not a concrete, but it's similar. It's a like plaster style core. It's pretty light, relatively inexpensive, and it goes on pretty well if you know what you're doing. It's hard to get the joints perfect. That's something that people spend a lot of time working on, and sheetrock and tape guys who put sheetrock in are they're partially artists and they're partially technicians. There's a technical side of it, and then there's an artistic side of it. And I know it might sound a little bit weird, but a good guy, somebody who's really good at putting up sheetrock and can do it quick and it look good is invaluable. They're worth a lot of money because sheetrock hides all the sins that you have when you put up the studs, because there'll be mistakes, like you've got a little bit of a weird stud here and a weird one there, and excuse me, hit the microphone. Yeah, sheetrock hides a lot, but you have to make sure that you give your guy who's doing sheetrock a place to put his sheetrock or their sheetrock. See how this piece, these are representing sheetrock. There's an additional stud. You can see it right here. So there are different ways to do this. So this would be for this wall right here. So it's a partition wall. So you have a stud. You have your blocking or another stud where it comes in, but that stud will be a little bit wider, and your sheetrock can hit it. And the reason we want that is so that we don't end up with an edge, because sheetrock's pretty brittle. We end up with an edge that we can put a screw through, so it's not just hanging out there and it's fully supported. Same thing. So you've got this style. I prefer this style right here, where you end up with a true stud in each corner, so you positively engage the sheetrock, because right here, if you look at my pointer, in the 3-stud California corner, you're relying on nails or screws of this guy right here to positively support it. And not that there's anything wrong with it, but if not done right, this guy can become a little bit loose. This way is a little bit more positive, the typical 3-stud corner. I like this one a little bit better, but you can use this one. So yeah, the takeaway from this is planning walls. They need to integrate into each other in a way that will make sure they don't wobble or they're not unsupported. And then also what your wall covering is, meaning that your sheetrock, etc. So, moving on. Let's see. Okay. How to construct a header. So we've talked about finishing walls. We've talked about laying them out. We've talked about how they get put together. Headers. So, as I said, 1.5 inches wide is a 2x4. This is a good example here. So we've got a 2x6, so 5.5 inches by 1.5 inch, stood on edge. Then we have another 1/2 inch here, 1.5 inches, excuse me, here, and then we have a 1/2 inch. So what's that add up to? 1.5 plus 1.5 is 3, plus half is 3.5. Sound like anything we've talked about before? I'm going to give you a second. Think back to something else that's 3.5 inches wide, and I'm going to kind of point at it. Right there. Look, crazy. Okay. 2x4s are 3.5 inches wide. That being said, exterior walls in Vermont, we do use 2x4, but we try to go with something a little bit thicker to give us more insulation. Because, as you know, and on the morning I'm recording this, there's snow on the ground. Is what it is. So it's cold. So normally we do end up with something a little bit wider here, but for the most part, 2x4 construction is what a lot of you will see and what we're talking about right now. But this gives you a general idea. So 3.5 inch wide plate, which means that our header needs to be contained within that, because we're going to put sheetrock over this. And if it's too wide, so if it sticks up this way, you can see my mouse coming out of the header. If it sticks out that way, we're going to run sheetrock over there, and there's going to be a big bump, or the sheetrock's going to crack, and it's going to look like trash. So what we do is we use 2 pieces of 1.5 wide lumber, generally like a 2x6 or a 2x8, and then we use a piece of 1/2 inch plywood. I just realized that this says shedking.net. Plywood has a lot of markings on it, especially when it comes from a large manufacturer, so I just assumed for the longest time that that just was a manufacturer mark. Okay, just ignore me. No, don't ignore me. So, 1.5 wide, 1.5 wide, 1/2 inch, 3.5 inches, boom. No super wide protruding header, and we're able to do that. If you look down here, there are different ways to insulate your header if it's an outward wall, because what we want to do is make sure that excuse me, is we want to make sure that that's not a place where we're losing heat. And I know in my house, a lot of the places that this wasn't done. This is something that you will see in probably construction within the last 15 to 20 years, as we've realized that if we build houses to the right amount of insulation, and then we control the airflow through them, they operate more efficiently, and we also don't have to pay as much to heat them, which is really important, especially since oil prices, propane prices, and whatnot have fluctuated and been high and low. And we want to be fairly rigorous with how we spend our money. So a little bit of extra foam in your header. You can see how this header is designed to be it still works the same way in terms of transferring the load, but it's offset a little bit. And there are a couple different ways to do this. But headers are one of the places that we do lose some heat, so it's a way to, excuse me, right here. There are 2 different ways to do it, and it is one of the places where we lose heat. And this is just 2 styles. There are different ways to do this as well. Okay. This goes back to where we started a little bit with talking about lumber dimensions. Our nominal versus our actual. Nominal means 2x4 is what it we call it. 2x6, 2x8, 2x10. The actual is what it comes to us as. Our 2x6s are a little bit thin for some reason. I've measured a couple of them, and they're not 5.5 inches, and that's actually why I updated the drawing a little bit, because we're ending up with some gaps, but I'll have to double check that for when we build, but no big deal. So 1/2 inch piece of plywood, actual is 15-30 seconds. It's close enough. Like, you're not going to notice that. In fact, that little bit of discrepancy is going to help us a little bit. Our 2x6, which is what we'll be using for our header, 1.5 by 5.5. We just have to make sure our jack studs come up and meet it. I highly recommend that you don't just assume that you put your header in first and then measure your jack studs to meet it, because, as I said, Ours have been a little bit variable. They haven't been a true 5.5, and they've been leaving us a little bit of room. So this is just for you guys to think about lumber, because when you go to order this stuff, I've been ordering steel and lumber and various other construction items for a long time now, and I still screw it up regularly. Not all the stuff, like one thing I'll be like, oh, that's 5 3/4 inch instead of 5.5, or stuff like that. So wood in general, length. So 2x4, our 2x4s are 8 foot long. Always double check them because they can vary a little bit. Thickness, when we're talking about like that for here, 1.5 inch, that would be our thickness, and our width, which is our face, 3.5 for 2x4. Or if it's or if we're ordering plywood, plywood normally comes in 4 foot by 8 foot sheets. So you would have and then whatever the thickness is, 11/32, 15/32 for 1/2 inch, etc. Okay. Okay, so this is the load path. So we've talked about how we lay everything out, what we put into it, what we make it out of. Now, why the heck are we doing this? It all comes down to making sure that whatever is above and is heavy gets down to ground. As I said early on in this presentation, if it is unsupported, it's going to sag over time. When that happens, things start to go wrong. When those things start to go wrong, you'll see cracks in your sheetrock. You'll see bulges in walls, and that's not what you want to have happen. You want a house to last. Yes, there is maintenance, paint, re-insulating things, updating, but you don't want the general main construction to be the thing that gets you. So our vertical loads, and we're not even talking about other stuff, we're just talking about straight down. Vertical loads come from above, and it could be the weight of the material, or it could be the people hanging out, and we'll talk about that in a second in the, I think 2 slides. So we have the load come from above, and we want it to go down to ground. Ground means the foundation, essentially. So it could be the foundation wall, which is a solid piece that is even if it's 6 or 7 or 8 feet above the actual physical ground, it's still transferring directly down, and it's tied in structurally. So you're not going to see the same type of flex that you would. It's a consistent piece. Or it could be the pad, which is so if you have a basement and you walk into the basement, the floor is is that pad part. And then we'll have what are called footings under load-bearing members, and it's hard to show. I've got a slide later on that'll come into that. But basically, we're coming from above. We're going through our studs, our header, our jack and king stud, and we are going to ground. And I'll talk about so here, our footing gives us a wider area, and that's what I was going to talk to you about later. From the previous slide. So we come down from above. Here's our foundation wall. Here's our footing. That footing distributes it into the ground. Same thing. And you can see right here we have our pad, or that larger opening in our basement, and we'll have footings underneath load-bearing areas that are free-spanning across. And it goes all the way up. Our roof, on our exterior wall, through our plates, into our concrete wall, into the ground. You can see the path. You can also see that we have load-bearing members here, load-bearing walls in the center, and they don't necessarily have to be directly in the center. It can be side to side. It's just, you could have one here and have the same effect, or it be asymmetrical. It all depends on how our our different components are designed to work together, and that's getting into the engineering component, which we're not really looking at. The other thing you can see here is that we have non-load-bearing walls, like we talked about all the way back here. Those non-load-bearing walls need to be well secured, but they're not vital in terms of making sure the house doesn't fall. They're basically keeping kids apart, keeping clothes contained, bathroom privacy, etc. So, talking about the loads that we see, and also talking about our footing. So, if you look here, we have two types of loads. We have live loads, which are people, stuff that we add. Then we have dead loads, which is all this stuff that makes up the actual structure. The one other thing we have is that we have tension and compression forces. So if we tie in here, it's going to be pulling and pushing. Excuse me. Depending on how it's used and how the live loads and the dead loads interact. The next thing I want you to look at are right here, our footings. We've all seen this. In fact, I have a deck that I need to replace in the next couple of years that pretty much every footing looks like this. And this could come from a couple different things. This could be, hey, the ground is just shifted, this was done right, and you can see that this guy goes pretty far down. The other thing is it might not have been deep enough. In Vermont, especially, every year, the ground freezes. The last year, the year we're experiencing right now, or the season we're experiencing right now, it froze not super deep, but what happens is, as you know, the ground freezes. And when the ground freezes, that frost goes down a certain amount. I can't remember what year it was, but about, I think 3 or 4 years, maybe it was 4 or 5 years ago now, we had a really, really cold winter. And the frost got down really far. We normally use 4 to 5 foot as a level of how deep the frost goes. So all of our water pipes, all that stuff gets put below what we call frost in the ground. They get dug down 5, 6 feet, sometimes deeper, just to make sure, because there are instances where it gets really deep. But what happens is, think about an ice cube. Ice, when water freezes, it expands. When it expands, it pushes, and in the ground, if it gets up and underneath a footing, it'll push the footing up, and then it'll settle back down. So that can happen like this. The other way it can happen is that the ground is a little unstable. Underneath there was something like a reasonable sized tree branch that rots away, and then it settles in, or just by virtue of the dead and live loads, the soil underneath compacts over time, and it changes. So, okay, it's just saying our footers can move, and that we have different loads we're dealing with. We have the weight of the structure, we have how the structure is going to be used, and we need to make sure that it's supported correctly. And also you can see right here, wind. We really don't get into that because, again, that's getting more in the engineering side of things. So we've talked about how to lay studs out. We've talked about the orientation of walls. We've talked about the different components of walls. We've talked about sheetrock. We've talked about live and dead loads and types of lumber. So when you're driving by a house and you see it, and you're like, okay, that house over there that has that roof, there are different types of roof styles. Here are 3 of them. These 3 categories get you a long way. The reason for that is because a lot of them, you've seen these 3 styles. And once you've seen these 3 styles, they kind of get put together in different ways. There are others, don't get me wrong, but this is what you're going to see a lot. Gable roof. you can see that's the normal, like when someone says draw a little picture of a house, this is the one you draw. A gable is your standard pitched roof, and a pitched. This is where. So those of you who've taken algebra, y equals mx plus b. This is where slope actually comes into play in the real world. There are other places, but for those of you who have been like, oh, I don't understand algebra, I don't like algebra, and for those of you who have been like, I love algebra, algebra is so cool, it helps me understand other things and whatnot. For both of you, this is where a real world application that both of you can come together and really see how it works. So we rise X number of inches and we run. That's called the slope of our roof. That's that gable end style. And depending on our rise and our run, that will give us the pitch of the roof. Does that make sense? I hope it does. Because that's one of those things. It's really interesting for me because I learned the algebra stuff, and it takes me a second to convert it over into talking about construction, which is kind of interesting because some people will hear the construction stuff and be like, because in construction there's a bit of a shorthand, like a 12-12 means 12 inches over, 12 inches up. Pretty steep roof. Okay. Let's see. So gable end. You'll see that our main load bearing occurs in these walls. We still have load bearing in this wall and the other wall, but the whole roof is basically sitting on these guys. And this is actually, this end is the gabled end, or the gable end. And you'll see this in like so many different houses, especially in this area, and then you'll see them put together in different ways. Gambrel. You see this mainly in, right now you're saying barn, older barn constructions and newer sheds. What's really nice about this is that you end up with a lot more headroom in the second story. This one, you end up with about, I think it's about a third. So like if you think that you want about an 8-foot ceiling, only in the center you're going to get your max, because you have a piece that ties in across here that keeps the lateral loads together, and then you lose it pretty quickly. So you end up with this pretty narrow space that's at the full height you want. A gambrel, you end up with a lot of volume. That second floor, it's a little bit harder because you don't have like this nice straight, even side, which is just really easy to deal with, and you're just dealing with straight shots with your lumber when you're building this. This is a little bit more complicated angle-wise, but the thing is that think about, this was used as a hayloft mainly. So you want a lot of volume because you want to maximize putting hay and stuff up there. From a standpoint, from the standpoint of housing, again, you have a huge area that you can use that's full height. Here you might have to put what's called a dormer in, which is basically a little, I don't have a picture of it, but a little roof that comes out here that allows you to use that space. Then we have a hip roof. Not a lot of room up top. This is basically, you can use them in multi-story structures, but a lot of times you'll see them in single-story. Angles are pretty hard. It's a sturdy roof because it helps with that load distribution. But it is hard to get, because you've got like, this is like where being really good at math really comes in, because you've got some weird angles, and they look pretty good. As I said, I've seen them more in one-story constructions, just because it doesn't allow for a great second floor. Okay, so we've talked about load bearing, and as I'm doing this, I think I'm going to, not for you guys, but eventually rearrange this, because I think this would make a little bit more sense. We're jumping a little bit, so I apologize for that. So, if you look here, take a look at our header. Take a look at our header. One of these is right, one of these is wrong. This piece right here goes over, it's some type of strapping. So this header goes from here all the way over to here, and then down. This header does something, and you can probably tell by the way I'm talking already that which one's right, which one's wrong. No, that little thing didn't work. Okay. So, this one is right because you have supported on either end, it's supporting what's above. This one is wrong, so even though we've got these big cripples above it, there is absolutely, unless this goes into here and then down, there is absolutely nothing supporting this end. So, it might continue over this way, I'm not sure, but just at face value, it looks like it terminates above this, so it's basically not doing anything. There might be some hidden parts here that we're not seeing. It might extend farther, but at first glance, this one is correct because it's supported underneath. Our weight is borne above and transferred down. This one just looks like it's hanging out there and someone made a huge mistake. Okay, so I'm going to stop there for this video. That is the construction side of things, and then we'll get into the wiring. If there are any questions, you can email me, or we could set up a Google Hangout thingy, which I haven't done yet, or Zoom, or whatever we're going to use, and we can talk about this more. So, went over quite a bit. It's about an hour in, and look back for the how electricity works in residential situations.